Welcome back, young math padawans. It's Mrs. Angel with lesson 3 on quadratics, one of the methods for solving one in standard form. So standard form, if we recall, is in the form ax squared plus bx plus c. But since we're not graphing here, instead we're solving, all of our equations will be set equal to 0 instead of set equal to y. So this method is very similar to solving in intercept form. In fact, the first step here is to convert it into intercept form, and we do that by factoring. Because factoring means to take something that's a sum or a difference and turn it into a product, in this case, a product of two binomials. And then we're going to apply our zero product property, like we just did in the previous lesson. So grab some notes and let's get started. So here we have a quadratic in standard form. And again, rather than being set equal to y, as it would be if you were graphing, it's already set equal to 0. So at this point, it's not as simple as just looking and seeing what values of x it has to be to make it a 0. We need to get this into a product of two binomials, get it into intercept form, and from there, we can apply our zero product property. Well, how do we do that? We do that by factoring. So there are a lot of methods that we could use for factoring. In this case, with quadratics, you will never see a quadratic that has more than 3 terms, so we don't have to worry about the 4-term polynomial. However, we may be given quadratics that are binomials or trinomials. So let's take a look at the quadratic from example 1. So looking at this expression here, this is a trinomial. So automatically I'm looking at the green box. Does this trinomial have a leading coefficient? No, which means the method that we're going to use to factor this is our P's and Q's. So let's go ahead and do that. To factor using P's and Q's, we find two numbers that have a sum of the middle term and a product of the last term. What has a product of 49 and a sum of 14? What about 7 and 7? 7 times 7 is 49, and 7 plus 7 is 14. So those are my values of P and Q. So coming over to our product, x times x is how we get x squared. And a positive 7 times a positive 7 is how we get 49, and those also add up to 14. So what did we just do? We just took a quadratic out of standard form and converted it into intercept form. And why did we just do that? Because now we can use the zero product property. Now we can set up and solve equations or just use mental math to figure out what our values of x are. So go ahead and finish solving from here. Wait a minute, I ended up with -7 for both of them? That's weird. Well, when I go to check, since -7 is the same number, would I check it twice? No, that just means that at most, this quadratic can only have one solution. Let's check it just to be sure. Now, here's the catch. When you're checking, you always want to check in your original function. So you don't want to check it into the function that you created, because there's a chance that you did your math wrong. That means we're checking in the standard form. So let's go ahead and substitute in -7.
-7 squared plus 14 times -7 plus 49 equals 0. 49 plus -98 plus 49 equals 0. -49 plus 49 equals 0.
And 0 equals 0. So it appears -7 is correct. So what does that mean? This means that the quadratic has one 0, and that only 0 is at -7, 0. In this case, the vertex and the 0 are the exact same point. All right, on to example 2. Right off the bat that I see it is a trinomial with a leading coefficient of 1, which again means that we're going to factor this using P's and Q's. So go ahead and try factoring this into intercept form now. Great work. So hopefully you would have ended up with -4 and -5, meaning b minus 4 times b minus 5 equals 0. What did we just do? We took a quadratic out of standard form and put it into intercept form. So now we can use our zero product property. So after solving, or frankly just looking at it, I ended up with 4 and 5. So now I'm going to check both of these in the original standard form function, starting with 4.
4 squared minus 9 times 4 plus 20 equals 0. That's 16 minus 36 plus 20 equals 0. That's -20 plus 20 equals 0. And
0 equals 0, meaning that 4 is a solution. Now let's check 5. And 0 equals 0, meaning 5 is also a solution. So what does all this mean? This means that the quadratic b squared minus 9b plus 20 has two zeros. They are 4, 0 and 5, 0. On to example 3. Ooh, this one's a tough one. This is actually in standard form. It's just missing that third term, that constant. So that means this is a binomial. Let's see what method we would use to factor. Okay, so we're looking at a binomial, which means that we're looking at the yellow box. Is this a difference of two squares? Well, it is a difference, but 6n squared is not a perfect square, and neither is 30n. So that just means we're just going to factor out the GCF, and then we're done. That seems simple enough. So here we go. What is the greatest common factor of 6n squared and 30n? Well, 6 goes into both 6 and 30, and both of them have at least one n in common, which means the GCF, or the greatest common factor here, is 6n. So 6n is the first factor in my new product. But what's left behind? Well, after I take 6n out of both of these terms, what are we left with? N. And 30n divided by 6n leaves us with just 5. So now we have taken something from standard form and put it into intercept form. And from here, we can solve using zero product property. So go ahead and try that on your own. So whether you use mental math or solving, I ended up with 0 and 5. So I'm going to check both of these in the original function in standard form, starting with n equals 0. And it would appear that 0 is a solution. Now let's check n equals 5. 0 equals 0, meaning 5 is also a solution. So what does all this mean? This means that the quadratic has two zeros. They are 0, 0 and 5, 0. Final example, and this one's a little tough because we have a trinomial, but this time we have a leading coefficient. So let's take a look at our factoring methods to figure out what we're going to do here. Trinomial with a leading coefficient. So the first thing we look for, actually, before even that, step 1 is always to look for a GCF before even going into the green box. Do these three terms have a common factor? We have a 2n squared, a 2n, and a 24. They do have a common factor, 2. And if I were to factor out 2, that would be a trinomial without a leading coefficient. Okay, so here we're going to factor out the GCF 2 first, then we're going to factor it using P's and Q's. So if I factored out this GCF 2, that means 2 is now going in the front of my new product. That means I'm essentially dividing each of these terms by 2. So what does that leave me with? Well, that leaves me with n squared plus 1n, or just n, minus 12 equals 0. So now, inside of the parentheses, I have a trinomial with a leading coefficient of 1. I can factor this using P's and Q's. Why don't you try to finish factoring now? Okay, so the two numbers that add up to 1 and have a product of negative 12 are negative 3 and positive 4, putting it into intercept form to my right. 2 times n minus 3 times n plus 4 equals 0. Go ahead and find the zeros now. Great. So whether you use mental math or set up and solve the equations, I ended up with 3 and negative 4. But there's only one way to find out if I did it right. Checking both solutions in the original standard form function. That means the original one with the leading coefficient of 2. So let's go ahead and do that now. And 0 equals 0, so n equals 3 is a solution. Now let's check negative 4. And since 0 equals 0, negative 4 is also a solution. So what does all of this mean? This means that the quadratic here has two zeros, and they are 3, 0 and negative 4, 0. So again, one of the many methods that we can use with standard form is to convert it into intercept form and then use the zero product property to solve. This only works if the quadratic can be factored. So in next lesson, we're going to learn about the other methods for standard form. For now, that's the end of our lesson, and I will see you next time.